बच्चों, कल हम लोगों ने मैथ्स का चैप्टर किया था, सेट्स का चैप्टर किया था एंड इट वाज पार्ट 1। आज हम लोग क्लास 11 मैथमेटिक्स का चैप्टर करेंगे, सेट्स पार्ट 2। चलिए देखते हैं कि पार्ट 2 में हम लोग क्या पढ़ने वाले हैं। इसमें हम लोग सबसे पहले पढ़ेंगे टाइप्स ऑफ सेट्स। पहले देखते हैं द एम्प्टी सेट। एम्प्टी सेट क्या होता है? चलिए इसको समझते हैं थोड़ा सा, वी विल अंडरस्टैंड। सपोज देयर इज अ सेट ए। X is such that X is a student of class 11 presently studying in school। इसका मतलब उस स्कूल में जो 11th क्लास के बच्चे हैं, जितने भी बच्चे पढ़ रहे हैं 11th क्लास में, उनका ये सेट है। एंड दिस इज अ वेल डिफाइंड सेट, क्योंकि हम जा सकते हैं, हम उसको काउंट कर सकते हैं कि भाई कितने लोग पढ़ रहे हैं, और उनका एक सेट बना सकते हैं। करेक्ट। तो इसका मतलब क्या है, ए जो है ना, दिस कंटेन्स फाइनाइट नंबर एलिमेंट्स, और यू कैन से स्टूडेंट्स। करेक्ट। अब इसी की जगह पे हम लिखें सेट बी। सेट बी इज एक्स। एक्स इज ए स्टूडेंट प्रेजेंटली स्टडीइंग इन क्लास 10 एंड क्लास 11। अब इस सेट का क्या मतलब है? हमें ऐसे स्टूडेंट्स का सेट बनाना है जो क्लास 10 में भी पढ़ रहे हैं और 11 में भी पढ़ रहे हैं, बट इज दिस पॉसिबल? साइमल्टेनियसली कोई भी स्टूडेंट क्लास 10 में और क्लास 9 में साइमल्टेनियसली नहीं पढ़ सकता है। तो इसका मतलब क्या है कि जो सेट हमारा बी है, इट कंटेन्स नो एलिमेंट। इसका मतलब क्या है कि यानी कि सेट बी जो है वो हमारा एम्प्टी सेट है। इट हैज गॉट नो एलिमेंट। करेक्ट। सो एम्प्टी सेट वी कैन से a set which does not contain any element is called empty set। इसको हमने ये भी बोलते हैं और नल सेट, और we can say wide. This set is null or the set is wide set. Correct. I hope you understood this. Now, इसको हम लोग कैसे डिनोट करते हैं? ऐसे सेट्स को हम डिनोट करते हैं फाइव से, और जस्ट ब्रैकेट and there is no element. Let us see some more examples. Suppose some set is there, x. X is such that 1 is less than x is less than 2, and x is a natural number. This is an empty set because x is in between 1 and 2. That means x can be a fraction. So a fraction cannot be a natural number. So it is an empty set because there is no natural number between 1 and 2. Another example we can see, be x square minus 2 is equal to 0, and x is a rational number. Now, this set is also empty because this x square minus 2 is equal to 0 is not satisfied by any rational number of x. Because x is a root 2, which is a basically irrational number. Correct? We can see some more examples. Suppose C is a set of x and x is such that x is a even prime number greater than 2. Now there is only one prime number which is even prime number, that is 2. So there is no prime number greater than 2. So it is a empty set. Correct? So these type of examples are basically. Next, let us see what are finite and finite sets and infinite sets with a simple definition. When there are finite numbers in the set, then it is a finite set means when there are finite number of elements. A, B, C, D, E. Or we can say men living presently So if you see here, we have finite number means suppose if how many numbers are there in set A is denoted by this. So here it is 5. Here and B, here it is again 5. Here it is also a finite number. So these are all non-empty finite sets. Correct? Now, if we see, suppose let G be the set of points on a line. Now, there will be infinite number of points on a line. So G is basically infinite sum. Correct? So at a definition, we can write a set which is non-empty. Hmm. Or consist of definite number of now definite number of elements is called finite. Or otherwise, here we can make a correction. Here it will come empty because empty set is also a finite set. Correct? Or otherwise, the set is called infinite. I hope this is clear. correct? Like the set of natural numbers. Set of natural numbers is basically 1, 2, 3, and it will go like that. So this is a infinite set, correct? All infinite sets cannot be described in the roster form. Like here it is natural number, you can write in the roster form. Suppose it is a set of real numbers. It does not have any pattern. Correct? Does not have any pattern. So it is difficult to represent them in the roster form. They can be represented only in the set builder form. Correct? Now, let us see this example. State which of the following sets are finite and infinite. Correct? In this set, if you see, your x is equal to 1 and x is equal to 2. Both are natural numbers. So, or let us write that. Suppose example number 1. In this case, x is equal to 1 and 2. These both are natural numbers. Correct? So, this set is basically 1 and 2. And naturally, this is a finite set. Example 2, here, if you solve it, then x is your x square is 4. That means your x is plus minus 2. But here x is equal to 2. This this is a natural number. So the given set is basically, this is also finite. Correct? Then 2x minus 1. 2x minus 1 will give you 2x minus 1 is equal to 0, or x is nothing but 1 by 2, which is not a natural number. Correct? That means your set is, so this is also finite. Correct. Fourth one is basically X is a prime. Now X is prime. So all the prime numbers will be basically natural numbers, but there will be infinite prime numbers. Hence, this set is basically infinite. The last one is X is odd. And X belongs to natural number. So all the odd numbers you have to list down, but there will be infinite number of odd. So this set is correct. So this is basically your this thing. Now let us proceed further. Equal sets. Two sets A and B are equal if they have exactly same number. Then we can write it as A, set A is equal to set B. Like your A is 1, 2, 3, 4, and your B is so 2, 3, 1, 4. They have got same elements. That means A is equal to B. Correct. We can have another example. Suppose A be the set of prime numbers. Less than 6. And P be the set of prime factors of 30. Now, if you see, A is a set of prime numbers. So you have 2, 3, and 5 in this set. And prime factors of 30, what are those? Prime factors of 30 less than 6. This will also be 2, 3, 4. These two sets are basically equal sets. Now suppose you have Now suppose you have A like this, and you have B 2, 2, 1, and 3. Now here you can see this 2 is repeated. But still, these sets will be equal because all the elements of A, they are in the B. And in fact, this is not the correct way of representing any set because elements are generally not repeated. Correct? Let us see this example. Find the pairs of equal sets, if any, give reasons. So you have A and its element is 0. You have B where X is such that X is greater than 15 and X is less than 5. What that means? X is less than 5 and X is greater than 15. So in this basically this 0 element does not come. That means A is not an equal set of B. Here, here C is basically only one element, that is 5. That is A is not equal to C also. And since X is less than 5, so basically C is not equal to B also. Let us see here. This D is basically a set of -5 and 5. Correct. Here, -5 and 5. That means D is whether, just see whether it is equal or not. Anything. Let us one by one we will see. A is not equal to B, A is not equal to C, and A is not equal to D also. And let us see, is the integral positive root of the element this thing. So E is nothing but your 5. Correct? That means E is equal to C. Let us see C. C is equal to E, but C is not equal to A. We have seen C is not equal to D. Correct? As far as D is concerned, D is not equal to A, D is not equal to B, and D is not equal to E also. So there is only one pair, E and C, they are equal. Correct? I hope in this, let us see this question. Which of the following pairs of the sets are equal? Justify your answer. It's a set of alloy and set of letters. This thing B. That means here A L O Y. Only these alphabets are there. Here also A L O Y. They are also same. That means in one X is equal to B. Correct? Then let us see two. Here N belongs to integers and N square is less than or equal to 4. That means A, we can write it as in roster form integers -2, -1, 0, 1, and -2. Correct? Because N square is less than 4. And what about B? B is basically, it is the H belongs to R, that is real number, and x square minus 3x is 2 is 0. Means its root will be basically x is equal to 1 and x is equal to 2. That means 1 and 2. That means this shows A is not equal to, correct? Now, let us go further. Another important thing in this chapter which is to be learned is subset. Now, suppose you have X is a set of all students in the school. And Y is set of all students in particular class of that school. That means elements of Y, they will figure in X also because X is the set of all students. And in those all students, that particular class student will also be there. That means we can say Y is a subset of X. It is denoted by like this: Y is a, okay, this symbol, it stands for is a subset of. So Y is a subset of X, or we can is contained in, means Y is contained in X. So definition wise, if we see, definition wise, if we see, then we can write it as A set is said to be a subset of a set B if every element of A is also an element of B. Correct? So this is the definition of a subset. A set is said to be a subset of a set B if every element of A is also an element of B. Correct? That means if A is a subset of B and A belongs to A naturally, then A also belongs to B. Correct? So we can write this thing in a form like this. A is a subset of B if A belongs to A. This implies that. What is this? Implies. Means if A belongs to A implies that A also belongs to B. Correct? And suppose if A is not a subset of B, then we write it as A is not a subset of B. And in this way, we can see if A is a subset of B and B is a subset of A, means every element of A is in the B and every element of B is in the A. This shows that this is possible only and only if A equal to B. Yeah? All the elements of A are, this is basically what is the sign? If only, if, sorry, if and only if. Correct? If A is a subset of B and B is also a subset of A, that means they are mutual, means all the elements of A belong are the elements of B also. That's why they are correct. This follows that A, that is A equal to B, this follows that A is a subset of A, means every element of A belongs to every element of A. So, correct. So, this is one thing, and your empty set phi has no element. So that means we can also say phi is a subset of every set. Phi is a subset of every set. Correct? Now, let us see very important result. Q. Q is what? Q is basically set Q of, it is a set of rational numbers. Naturally, it is a subset of all the rational numbers, they belong to real numbers because real number consists of all the rational numbers as well as irrational numbers. Correct? So we can write it as Q is a subset of R. Likewise, suppose if A is a set of all divisors of 56 and B is a set of all prime divisors. Now, all the divisors of 56, those prime divisors will consist of here. So we can write it as here B is basically a subset of. Correct? Or here we can see, suppose you have A 1, 3, 5, and you have B X, and X is E an odd number, odd natural number, you can say, less than 6. Then what is B? B is also basically 1, 3, and 4. That means here A is a subset of B and B is a subset of A, and this implies that A is equal to B. Correct? Fourth example, we can see, suppose you have A, which is a set of vowels, correct? And B is a set of, suppose A, B, C, D. Here, A is not a subset of B. And also, B is also not a subset of A. Correct? Now, suppose you have A and B, two sets. And if A is a subset of B and A is not equal to B, then A is called a proper subset of B. Correct? So this is called, this is, so mind it, this condition. So for a proper set, proper subset means if A is a proper set of B, then A should not be equal to B. And in this case, A is called proper subset of B and B is called superset of A. We can see the example. Suppose A is 1, 2, 3 and B is 1, 2, 3, 4. That means A is a subset of B and A is a proper set of proper set, proper subset of B. Correct? Or we can say B is a superset of A. Now another thing, if a set has only one element, then we call it a singleton set. Correct? That means this, suppose this is having one element, is a singleton. Got it? Very simple. Understand it only for once, but understand it properly. If you understand the things properly, each and every element of the chapter then you will never forget. Correct? Mathematics is such a subject. Now, this is one question. Consider it's an empty set. A is there, B is there, and C is there. Correct? So phi is a set of B, of course, because phi is subset of every set. Phi is subset of every set. Now, what is the relationship between A and B? A and B, basically, if you see, it is not a subset of B because there is an element 3 is there, but in this 3 is not there. What about A and C? Of course, A 1 and 3 they belong to C also. So is a subset of this thing. What about B and C? B and C. B is also a subset because element of B, every element of B belongs to C. Correct? There is, let us see this thing. If A, B, C are three sets, if A belongs to B and B is a subset of C, is it true that A is also a subset of C if not given? Correct? So it is not true. Suppose we can take an example. A is a singleton set, one element is there. B is a set, and of course, this element 1, or you can say set A1 is 1 belongs to B, and this is, and let us see C. C is suppose 1, 2, and 3. Now let us see. A, if A belongs to B, here A belongs to B because the set A is the element of B. And B is a subset of C. So you see, B is also a subset of C. So these two conditions are fulfilling because all these two elements, if this condition is fulfilled, then it says whether A belongs to C, sorry, A is a subset of C or not. In this case, A is not a subset of C. Why? Because A1 is the element of A. But 1 does not belong to C. 1 belongs to A. But 1 does not, because here this is basically set A. So an element of a set can never be a subset of itself. Means an element of a set can never be a subset of correct. So this was basically about subset. Now let us go further. Subsets of set of real numbers. Correct. So we have these subsets. Suppose these are the subsets set of natural numbers. It is a basically subset of real number. Hmm? Set of integers. This is also a, then, or here we can write is natural numbers means n, integers means z, or rational numbers. It is also a subset of real numbers. Correct. How to denote Q? Q basically, if you see, you can denote Q x. X is such that P by Q, correct? Where P and Q, they belong to integers. And Q should not be equal to 0. This is how rational numbers, we have seen all these things in other classes. Correct? So these are the basically subsets of real numbers. Then what about irrational number? T. T is basically irrational numbers, set of irrational numbers, you can say. We can define this like this. Means real numbers basically consist of rational numbers and irrational numbers. So the numbers which are not rational number, they are irrational number. So we can define that way. X, X is such that X belongs to R and X does not belong to Q. Q means rational numbers. Correct? So T, what T is basically, you can see root 2, root 5, pi. These are all irrational numbers. Correct? So we can write n natural numbers. It is a subset of integers, which is a subset of rational numbers. Correct? Then Q is a subset of R. T is a subset of R, and natural numbers, naturally, they are not the subset of irrational. So this is the obvious relationship between these two. Correct? Now another important thing which is there, that is interval of intervals as subsets of R. R means real number. Generally, we write A and B, they belong to real number. And A is less than. That means it is a element of all those elements, real numbers, which are in between A and B. Now, this type of interval, this is called open interval. Suppose you write like this is called closed intervals. Because this interval is including A and B also. Whereas in this, A and B, they are excluded. Correct? So we have a particular way of defining this thing. Like, suppose if we are writing like this, sorry, this is closed interval. Means here X, this is basically closed interval. And if we are writing like this, that means this is open interval. Means we are not including A and B. Correct? We can have this kind of interval also, like A is closed, but on the B side it is open. And or A is open means A is not included, but only B is included. Correct? So these four types of intervals you see generally on the line when you will see mathematics. Generally, if we denote A and B like with the holes, means empty holes are there. This is basically what is interval? This is open interval. And if we denote like this, that means this is closed interval. Both A and B are included. Suppose, suppose this is your closed and this is open. Then here, basically, we can write it like this. Or so this is the way of representing the intervals in the graph. Wherever, suppose wherever infinity and infinity, plus infinity or minus infinity are there, these intervals are always open. Like these intervals are always open. Whenever infinity is there, this is from A to minus infinity. A is included. But wherever Kanachiye, the things are interval is extending up to minus infinity or plus infinity, then those are open interval only. Correct? So this was all about this thing, intervals. Now let us cover this thing also, universal set. Now, universal set we can define in a some particular context. Correct? Suppose if we are studying about numbers, then your real numbers can be a universal set. Correct? Or suppose if you want to study some human population, studies, then your universal set will be all the people of the world. Generally, universal set is denoted by U. And all other things are its subset like A, B, C. Like suppose universal set is real number, then natural numbers, rational numbers, irrational numbers, they will be subset of real numbers. Correct? So with this, basically, I'm concluding this part 2. In this chapter, what is remaining is the Venn diagram. So tomorrow, we are going to study about Venn diagram. Correct? So how was this video? Please do tell me in the comments box, and please subscribe my channel to have the full series of the class 11th mathematics, and then after that class 12th chapter, all NCERT chapters. Correct? Thank you very much.